Hello and welcome to our IP and IC Working in Concert series, where we're going to look at using IC as an advanced data management and visualization toolkit for your IP wells. I'm going to take the next few minutes to talk about displaying your IP analysis results on an IC map. To understand the potential impact of our well data across our study area, be that a regional review of offset wells or a more detailed analysis of particular wells in an underperforming field, we shouldn't work in isolation. Utilising the mapping tools within IC, it's easy to visualise the lateral variation in our petrophysical well data, rather than limiting ourselves to identifying any vertical changes throughout the well. Building a suite of quick look grids within IC, we can identify any spatial variations or trends, allowing a deeper, more holistic look at our wells, leading us to identify potential sweet spots or areas in need of further study very easily. Let's get started. I have IP open here with a dozen wells in which I've done some analysis. The next step, I want to see them on a geographic canvas. All of our tools for IC can be accessed through the Advanced Interpretation Toolkit. Once the synchronization has started, IC's license is accessed and the synchronization configuration toolkit is opened. This is where you can choose which wells are included, which curve sets are included, and which parameter results are included in the synchronization. Once IC is open, you'll see the same list of wells in the browser, and you can also dig deeper and see which data is sitting under each well. Anything with the IPP set prefix is what has come in from IP originally. Once we're in IC, we can open up our map canvas and start building those visualizations. Right now, we have our toolkit showing us which wells are included, and we can also see our well paths, our well symbols, our key scale, and our north arrow. Additional items can be added, and these are listed under our Layers tab. So resources such as your coastline can be added very quickly. The focus for today is our gridding. Within IC, we have several grid types, including structural, thickness and log statistics, that can be added and created within IC. In addition, we have an option to import external grid files. These are your seismic interpretation surfaces that have been created in your seismic packages. What can also be brought in are things like your fault polygons from that same interpretation. For example, here I have a structural surface called the top EV that was made before, and dragging on shows us our highs in our oranges and our lows in our blues, purples. There are several ways you can modify grids within IC. For example, adding in a fault polygon. I can draw a polygon directly on my map to help explain why I have such severe changes in our structural surface. Adding this fault can have a knock-on effect to the surface itself. We can redraw this surface based on the presence of this fault. A very simple change in including that fault in my grid calculation can allow us to show the difference from our northwest side and our southeast side very easily. Another way to change the map is to add in things like a pseudo well. You can add a pseudo well easily by adding an additional point based on the value of somewhere else. We can finish editing very easily. The methodology behind the grid itself can be changed and produce completely different results. We have several options, and you can see the variations based on the input. Anything that can be modified manually is editable. Everything we add to these, including that fault polygon we made and the EV structure, has been added to our layers list. So if we want to make our own surface, let's base it on our IP interpretation, we can go in and choose, sure, we could go and choose a thickness map and zone up our EV, but let's go in and look at some of our log statistics. So the first thing we need to do is decide which zone we want to use. We can choose the table. If we use our IPP set tops, we can choose our EV. I have a structural EV. Let's have a look at some values for within the EV. And we can then have a look at any of the logs that have been brought in from IP. So you'll see the IP underscore prefix will help us identify any of the results from IP. The naming conventions remain the same. So for example, we do have some porosity data, we've got some V-clay, we've got water saturation. Let's use water saturation. At this point, we can choose what kind of calculation, what statistic we want to see. Average values, minimums, maximums, or any p-value. So we have the standard 50, 90. We can type in any value there we like. Let's just go for an average value. Then we choose which kind of gridding method we want to use, how smooth we want things to be, the size of our cells. Then how we want this to look. We can choose our colors. And once we hit apply, we will see the values as calculated for each of these wells and what display options we have with regard to the intervals, the contouring, and even the colours. If we want to highlight a particular zone, we can do that very easily. Once you've saved that grid, it will appear under your log statistics list and display under your layers. Once you have the shape of a grid, of course, you could go in and use that as the parameters for a new grid. We can go in and change what we'd like to look at. And we'll save a copy. Giving it a new name with our new inputs will produce a slightly different result. And you can build this suite of grids to help explain that spatial variation in the findings that you're seeing. For this case, our porosity values show a slight variation from our west to our east. What we've gone through should have given you a taste of what's possible to achieve with an IC mapping with your IP analysis data. You can easily access the IC tools directly from IP and generate an entire suite of grids that will allow you to answer some fundamental questions. For example, how do my porosity values change across my field within my EV reservoir? Or, is there a visible trend within my water saturation across my field? Understanding that spatial distribution of your analysis results will help you build that deeper understanding and a more holistic view of your entire dataset. Thank you all for watching. If you have any questions or comments, or even if you just want to be kept up to date with our latest news, please get in touch. The team's details are there, or subscribe by following the link.